The last day of solving equations, and I said yesterday that you would be best off if you did all the homework and made sure that you were very good at the first 2 days. And I'm just going to go back to this for a second because I believe it was here, where we put up, those are sort of 6 examples of the different types. And there's some overlap there, but you can see how, like, you know, some of them look similar to the others, but they're all kind of done in different ways. And so you gotta know how to do each of them. And if you don't, if you're already struggling with this and then we're gonna add on another whole new one, then that's where you start to get into trouble. And so again, a big part of this process is not just knowing how to solve it, but identifying what type and solving it that way. And whether you're doing a quadratic and you end up factoring or you end up using a quadratic formula, that's, to me, still the same type. Like, we're just identifying the type of trig equation it is. So in the top here, we've got, this is a quadratic. This one's a quadratic, but we need to do a swap out with an identity that we don't know. That's how you would solve that one, right? This one's a quadratic, but it needs a swap out first because I've got a cos 2x and a sine squared 1x and a sine x. I can't have sine x's and cos x's, or sine squared x's and cos 2x's. I can't have x's and 2x's in the same question. It's not going to work. Okay. This one's a common factor. It's in some ways, it's an easy one in a lot of ways, but it's actually one that trips people up and they start doing something wrong. Remember the other thing that I said? The bottom 2 are linear. Those are the only ones where you chuck all the junk to the other side and isolate for the sine x or cos x. Every other kind, you're setting one side equal to 0. Every other kind, right? And some people, for the common factoring one, for some reason don't do that. And they start doing it a different way. And they move the sine x over to that side, and they've got something on 2 sides, and it just all falls apart, and nothing makes sense. So you really need to recognize, you need to do enough practice, all of it, really, so that you know the different types and you're comfortable. It's so interesting how you can be confident with this stuff. And then all of a sudden the test paper is in front of you and you start to get doubts and you start to like, oh, maybe I don't do it for this one. Even though I said, no, you do it for every single one. And like, oh, maybe this one's different. No, it's not different, right? Like, some things are different, but this stuff is hard enough that it's, I'm trying to show it to you straightforward, no tricks or anything like that. So those are the types that we've already covered. As I said yesterday, we also added the quadratic formula in, makes it a little bit trickier. And we've seen all these different types today as one more new type. And these ones, the first ones, are typically linear, although they could be either. Okay, these kinds of questions could be linear or quadratic. But the difference is it's got a 2x in it, and it's not the swap out type. So we're not swapping it out the way we did the other ones. We're solving it as a double angle trig equation. And the first part of it is pretty easy, although it's a little bit, you make one little change, add a 2, and again, people start to doubt themselves and wonder if it's different, but it's not. It's the same thing you've been doing for a long time. But it's at the end, there's a couple of steps that are a bit different. That's what we're going to focus our learning on today is what you do sort of near the end of this question. Okay, and there's one thing in particular that's really interesting about it that's really important that we have to go over. So, like I said, this is like a linear. So how do I solve a linear? I throw all the junk on the other side. So the first thing I'm going to do is move the 2 over. And I get cos of 2x equals root 3 over 2. Yes? What do you notice about that? Adam? It's a double angle. Thank you. What else? Max? It's a special triangle one, so it's easier to actually, a few other people had that. We absolutely want to recognize that right away. If I did the question like this, cos of A equals root 3 over 2, then A related would be what? Pi by 6. So this is the same thing, except what's my A? Because in the past it was always just an X. What's my A in this question? Anybody want to guess? It's 2x. So in this case, it's a little bit strange, but it's 2x related equals pi by 6. For a little while, we were skipping this part and we weren't showing the 2x, like the x related or theta related, but we're going to add it back in for these questions. And you'll see why when we get to the bottom, because it's complicated enough that I think it's a good idea. Everybody okay with this? This isn't the hard part. It's a little bit strange, but so far, I think that part's pretty straightforward, pretty easy. As a sidebar, you could have something like this. Cos of x squared plus 7x plus 12 equals root 3 over 2. And then what would you get? You'd get like x squared plus 7x plus 12 related, I guess. I don't know. We don't do this, so don't worry. But like you could, right? It's whatever you're taking the cosine of. That's the expression that represents the angle. So that thing would equal, in this case, pi by 6. Right? You could put anything in there. But don't worry, we're not doing that. Now, notice back to the a. If I was doing it with just a, what would be my next step? This part's really important. Yes. And what does it tell us?
That cos is positive in the first and last part.
Very nice. And then I use that idea to find my actual answers. And what would those answers be? In quadrant 1, it would be pi by 6. And in quadrant 4, it would be 11 pi by 6. So we still do the same thing, but we're not talking about x. We're talking about 2x. So 2x is pi by 6, and 2x is 11 pi by 6. I'm gonna stress this a bunch of times. We have not yet divided by 2. I find the related angle. I don't divide by 2. If you do that, everything else you're going to do is basically going to be wrong. You cannot divide by 2 at this step. Okay? I find the quadrant 1 and the quadrant 4, or whatever they happen to be. Still haven't divided by 2. I get both those done first. Like, I wouldn't find this one and find x next because you're going to confuse yourself. Find this one, and only then do we divide by 2. And if 2x is pi by 6, then x is pi by 12. And think about that. Go back up to the question. Go back up to this cos of a. If I do cos of pi by 6, I get root 3 over 2. So if it's 2x, I put pi by 12 in for x. I multiply by 2. I get pi by 6. And when I take the cos of pi by 6, I get root 3 over 2. Like, that makes sense, right? If you sub back in for x at this step here, you sub in the pi by 12. When you multiply by 2, before you do cos of the thing, you get back the pi by 6. So it's important to think about this. You can always plug these answers into your calculator to check them. Left side, right side, check. And I would recommend you do that. There's another good reason why we'll get a bit of extra time on the test. Give you some time if you want to check over your answers. Any questions so far? We are not done yet. Oh, we haven't done this one. That's not why we're not done. So 11 pi by 6, solving for x. X will be 11 pi by 12. Okay? We're not done yet. But we got to think about something before we can continue. So I am going to draw. Are you guys good? Yeah. Question or anything? No? You sure? Okay. I want to remind you of something. You don't have to, you can watch this. I don't think you have to write this down. You can maybe sketch it later, but this is a really important part of this process, okay? And I want to remind you of something that's really important, especially for this course. We think when we're solving an equation like this, it has nothing to do with graphs. And I've been trying to convince you all year that's not true. It always has everything to do with the graph. And it's so cool in the next unit, we really start to see that take form. But imagine I'm thinking about how this is like graphing. So I'm going to draw a cos curve as best as I can with no scale or anything like that. then how is this like graphing? Well, I'm going to do root 3 divided by 2 on my calculator. I got 0.866. And I'm going to say, where is that? It's just below 1. It's somewhere here. So what this equation right here, after we've done a step, what that equation, the way I can think of it as a graph, as if I do something like this. Y equals cos of 2 theta when y equals root 3 over 2. So this is the line y equals root 3 over 2. Where does that red line cross the green graph? Solving an equation is also like thinking about the interaction of these functions. And we notice that it has 2 solutions. And there's the quadrant 1 solution. And there's the quadrant 4 solution, right? At the beginning of the curve and at the end of the curve. Quadrant 1 at the beginning of the rotation, quadrant 4 at the end of the rotation. Like it all matches. But what's that the graph of? Cos 2 theta? What do we know about cos 2 theta? What's important about cos 2 theta? Do you know? Yeah, we do. And that might be helpful, but we're not going to use it right now.
Shorter.
It's shorter. It's got a different period than cos of just theta. What's the period of this graph? Adam? Pi. It's half. The period is half. So watch. This is pi. Right? And that makes sense because that's not pi by 6. That's pi by 12. So it's been scrunched and it's like halfway to pi by 6. So this all makes sense. But now watch this. Uh-oh.
So there's 4 answers?
We are supposed to find the solutions to 2 pi. There's 2 more answers. Where are they? Hold on. There's 2 more answers. Where they didn't come out and like what happened here? I'm supposed to find all the places those graphs cross that line, or that function crosses that line up to 2 pi. And if we think about transformations, we understand that we would get 2 cycles of this function in 2 pi. So exactly what Lucas said, there's going to be 4 answers. How do I find the next 2? A couple people have their hand up. But you can try to think for yourself, how would you find them? Looking at that graph, how would you find the next 2? Lucas, what do you think?
Add theta related to pi and then subtract 2, or theta related from 2 pi.
Interesting, although we never got a theta related. But what you're thinking would work. That's not how we're going to do it, but that would work, you're right. If theta related was pi by 12.
Okay.
Which, remember, it wasn't. But you could do it this way. You could kind of do it that way and think about it like that.
Okay.
Yeah. Isaac, what do you think?
Multiply them by 2.
Multiply them by 2? I don't think that's going to work. Adam, what do you think?
Add the period onto...
Add the period. Now that makes sense to me because periodic functions exactly means if I add a period, I end up back in that same position on the graph. And then to this one, I add a period and it's going to take me there. So we add a period. And what's a period in this one? Awesome. Which in this case is pi. If the graph changed, which it won't, if it was like cos of 10 theta equals, you'd have a lot of answers and you'd have to figure out what the period of cos of 10 theta is, or 10x, and you'd have to add that on a whole bunch of times. But don't worry, we're not going to do that.
Wait, so I did this and I got it right, but that's because it's only right in this case because theta related is equal to theta because it's positive in quadrant 1.
If it wasn't that way, the way you're thinking would still maybe work, but I think this way is a little bit more simple because it works the same every time. But I think the way you were doing it would work with that mindset that you had. But yeah, if it was in other quadrants, you'd have to think about that.
Okay.
And you have to figure out what you're adding to or subtracting from or something like that, right? But you could do that. I still like that connection that you made. Okay, so now I find another x by doing pi by 12 plus pi, which is, and I wouldn't usually write this all out, pi by 12 plus 12 pi by 12, right? So what is that? Ooh, that's not really a 2, is it? So what would this be? 13 pi by 12. And same thing over here, I go x equals 11 pi by 12 plus pi. So 11 plus 12 is 23 pi by 12. And those are the answers that you would have got, right? If you had thought of pi by 12 as your related angle, yeah. So I've got 4 answers. Because this is a jumbled mess and I've got x equals x equals x equals x equals x equals everywhere, we write a summary statement for these showing all of our solutions. So please do that at the end. And I just go, therefore, x equals pi by 12, 11 pi by 12, 13 pi by 12, and 23 pi by 12. So again, to recap, and I'm going to make a little note here. Actually, I'll use orange. Right here and right here, I was adding a period, which in this case is pi. So the nice thing is that's what you're always going to do, but I hope you understand the reason why we do that, because you could memorize. I could have just said, oh, and by the way, there's 2 more answers, add pi to find them. And you'd be like, all right, I don't understand, but I'll do that, right? Oh, it worked every time. My answers match what's on the page. Like I could have just told you to do that, but obviously it's better if we understand why we're doing what we're doing, okay? So the graph, that sketch, is a nice visual of why, and I hope you understand why. And then if you did get a different question where it was like cos 4 theta or something, then you would at least have some understanding of how to develop a solution to that.
No, I figured it
Okay. Any other questions? We're going to do a couple more here. A couple more that I think are similar, and then one that's a bit different. Oh yeah, these next 2. Good ones.
For the first question, okay, I mean just not.
Yeah, that's fine.
But like, why can't you just like use the formula and go like 1 minus like 2 cos squared theta minus 1, and then just solve for like you can solve for like cos x that way?
Oh, why can't you sub in?
Yeah.
I didn't say you couldn't.
Oh, so we could do that?
I think in most cases that would work. You're going to see one case where that's a really bad idea, and you wouldn't want to do that. You wouldn't even be able to. But for these ones, I would ask you to do it this way because this is another skill that we want you to learn anyway. But if you did that, I would imagine it would work out. I don't see why it wouldn't. I've never even actually tried it, but I've thought of it, and I think it would work. The question was, why can't you sub one of the formulas for cos of 2 theta in there?
That's
Now-
what I originally did.
Yeah.
Yeah.
Oh, and did it work?
I didn't finish.
You didn't get all the way through? But what about if it was sine 2 theta? Because then you're going to get
Well, then can't you use
2 sine cos, and you would have to factor that to split them up, but it might not be factorable, right? So I think you would still kind of run into some trouble in some cases. But anyway, I've not tried it that much, but you'll see for sure in our last example why. Okay, yeah, I'm not going to do it that way. Okay, so let's do this one quickly. So what's different about this one? It's got the 2x again. It's cosecant, but again, and it's so, I kind of said this before, but it's so interesting how we sit in class and we understand what our teacher's saying, and we do the examples, and we maybe do a couple of the practice questions. We think we really have like an understanding of this, and then all of a sudden one of the questions has a cosecant, like your identity yesterday that had a secant of x minus y, and that threw some people for a loop, but it wasn't intended to. It's just, what is secant? It's 1 over cos. What is cosecant? It's 1 over sine. That's all it is. But all of a sudden, you've not quite seen it in the same way before, and for some reason, it confuses people. So we're going to see it a couple of times here. What am I going to do? I still bring the 3 over, divide both sides by 3. So I get cosecant of 2x equals 1 over 3. But we don't have a cosecant button on our calculator, and we don't usually solve things as cosecants or secants or cotangents for that matter. So what am I going to do?
The sine 2x equal to 3.
Very good. So that means the sine of 2x equals 3. So if I flip the left side, because sine is the reciprocal of cosecant, I have to flip the right side. And what's the reciprocal of 1 over 3? 3 over 1. So this should be relatively simple to do. That's not supposed to make this question way harder. What do I do next? Okay.
Is that not possible?
Why is it not possible?
Because if you divide 3 by 2, it's 1 1/2. That's not.
Yeah, but we wouldn't even be doing that yet because that wouldn't happen until the end. It's not on the graph. Remember, we talked about this a lot. Like the graph of sine and cosine only goes up to 1 and only goes down to -1. So if your answer's before you do shift, you could try in your calculator, shift sine 3. You get an error, right? So this is not possible. And be careful here. Yesterday I was using this terminology, not possible, because that isn't possible. Sine of 2x will never equal 3. But in this case, because it's a linear, it's our only thing, there's also no solution here. And if there's ever no solution, you need to state that. Therefore, no solution. So it wouldn't be enough. This is kind of a picky thing, technicality, but you need to say this. And in this course, it will come up a lot. Like a lot. So get used to it. Don't fight it. Where we interpret some kind of work and we state the nature of the solution, and if there's no solution, you say no solution. Like you don't say something else, you say no solution. And in other cases, we say other things. So because this is not possible, there is no solution to this whole graph. Whereas yesterday there was a solution, it was coming from a different part. So that's why I didn't use those words, no solution.
Are we going to be doing ones with vertical shift or vertical stretch as well later? So we have to consider ones that are greater than.
There's one. And what did we do? But we like isolated first, right? Yeah. No, but that's a really good question because cos of 2x can't equal the square root of 3, but 2 cos of 2x can. But we don't even really think of it that way.
Okay.
But you still could. That's a great question. I love that. Yeah.
So, for example, if it was like sine 2x is equal to -1, there would be 2 solutions only then?
Yep. Okay, let's try this one. This one looks suspiciously similar. So what do I do? Same thing. Take the reciprocal. But this time, instead of sine 2x equals 3, I get sine 2x equals 1 over 3. So this one's going to work because 1 over 3 is fine. And this one's different from the last one because 1 over 3 is not in the special triangles. So what do we do for this one? Yeah, shift sign on the calculator. And we get 2x related. Whoa. Equals. .3398. Remember, I do not divide by 2 here. Don't divide by 2. That's what you're going to want to do. All of a sudden, you walk out of this room and you start making up your own ways of doing things. Do not divide by 2. First, Sir, do you divide by 2 now? So don't divide by 2. What do we do next? We think of this as our related angle. And we go up here and we say, okay, it was positive. Where is sine positive? Quadrants 1 and quadrant 2. So quadrant 1 answer would just be that same number, 0.3398. And my quadrant 2 answer would be pi minus that. You don't have to say it, but just so that people can follow what we're doing here. And that should work out to, tell me if I'm wrong, try it yourself, 2.8018. Now you divide by 2. Divide them both by 2. So x equals 0.16. me do that again. I still have it here. Whoop, divide by 2. 1699, yep. The first one divided by 2. And the second one divided by 2 is 1.4009. Is that right? Yep, confirm that. Thank you. And then we just do the same thing. We don't have to draw the graph. We already know that there's 2 more answers and we know how to find them. I just add pi to both of them. So x equals 0.1699 plus pi. By the way, when I do this on my calculator, like I leave the number in there, right? I don't clear it. And your calculator should have a little button on it that says answer. And I'm going to try to remind me to do a little demonstration with the calculator before the end of the period, but after we're done all of this, because I want to show you something that is really useful, possibly for later in this course. Definitely if you're taking calculus, we use it a lot. And if you start learning how to do it now, it might be useful. So we're going to do a little calculator work a bit later. But if I leave it on my calculator, I'm not rounding. I'm not punching 0.1699 back into my calculator. I'm leaving it on there. Yes, Isaac?
Are you going to show us how to use the memory function?
Yeah.
Because,
Why?
well, because you can't leave 2 answers in one.
Say that again? Oh, yeah, I would have to punch it back in.
Yeah.
Yeah. So in this case,
So if you put memory for the first one, then do the second one.
you could do that too. I don't know if that's easier in this case, but you could do that. Because all I'm doing is shift sign 1/3. It's not too bad. Okay, so then x equals 1.4009 plus pi. And that should give me, I think, 4.5425. I got 4 answers here. Therefore, x equals 0.1699, 1.4009, 3.3115, and 4.5425. And then some people say like, hey, wait a minute, didn't you just say you can't have answers over 1 or less than -1? We have 3. That one's 1, that one's 3, that one's 4. These are angles. These are angles in radian measure. So these are fine. There's nothing wrong with these, right? It's funny how we come all this way and then we still get mixed up about some of those things from way back at the beginning about like the difference between the angle in radians and the ratio result that you get when you take the sine of an angle. So don't get those mixed up. There's a lot to this trigonometry stuff. Is everybody okay with that? Awesome. One more. I think we have one more here to do. What's going on with this question? It's quadratic. And hold on, it's still got double angles, but they're both double angles, so it's not a swap out.
Oh, so it's a...
If I did swap this one out, I would get 1 minus cos squared all squared. So I'd have a degree 4 cos term or something, and then I'd also have a sine, so that wouldn't make any sense. So like that's not going to work, right? So I can't just swap out all double angles because in this case, even if it would kind of work, you'd have a degree 4 trig expression that you are going to try to solve, and you don't know how to solve that. So that's not going to work at all.
Could you just do it the same way instead? You get 2x instead of.
Yeah, that's exactly right. So this is not in any way different from what we did 2 days ago or yesterday. We're going to solve it the same way like we did the other quadratic ones, except when we get to the end, we got to do the thing we just learned about how we find more answers, and we have to do 2 theta instead of just theta, or 2x instead of just x. So I'm going to very quickly do b squared minus 4ac, and it gives me 25. So what does that tell me? This is factorable. I saw a lot of people using the quadratic formula on the learning goal today, that was factorable. And I think some people had the wrong answer because you didn't have the right radicand. Should have been 169 under the square root sign.
169 squared?
Yeah, 13 squared. But 25 is square for sure. It's 5 squared. So go ahead and factor this. And again, I'm going to cheat because we got those ones there. And I don't know about you, but I'm thinking this has got to be 3 and 2, doesn't it? Like it's not going to be 6 and 1. It's got to be 3 and 2. So 3 sine theta and 2 sine theta. And which one's which? So I need the 3 to be negative, and the 3 comes from this, so that's negative. And the 2 comes from that, so that's positive.
Wait, isn't it sine 2 theta?
Yes, thank you. Whoa. Very good, very good. So 3 sine 2 theta plus 1 and 2 sine 2 theta minus 1. So we've got 2 different brackets to do here. That means, I hope you can follow me on this, sine 2 theta equals negative 1 over 3. And sine 2 theta equals positive 1/2. So what do we have here? Let's sit back and like observe and sort of analyze what we have here. What do we have, Adam?
Well, we have 1 that's in the negative quadrant.
Right, we haven't seen that yet. Very good.
And then 1 that's in the positive quadrant.
Good.
So 8 answers there.
Special triangle.
Good prediction. This one's kind of going to be wild. And what else do we notice?
Like you were saying, that special triangle, so one of them that don't get it.
Yeah, very good. One of them is going to be calculator, and one of them we don't need it, right? So we want to notice all of that. And I can only imagine if somebody's still not great at these, and they're still kind of trying to figure that out. Like, how overwhelming would that be to try to learn this and all the quadratic stuff and all the other stuff we did the last few days, and still be trying to learn your triangles and something like. This is what I'm saying. It's a lot, right? So it pays. You really start to see how it pays to keep up with your work. Let's do the easy one first. I get 2 theta r is.
Wait, which one's these?
Pi by 6, right? I think this one's easier because we can do most of it kind of in our heads without calculator, right? It's a little bit faster. Do not divide by 2 here. 2 theta is pi by 6. And 2 theta is, so it's sine now and it's positive, so it's quadrant 1 and quadrant 2. What's the angle with the related angle of pi by 6 and quadrant 2?
5 pi over 6.
Thank you. So 2 theta is 5 pi over 6. I get both those first before I do any dividing by 2. And I get theta equals pi over 12, and theta equals 5 pi over 12. And theta also equals pi over 12 plus pi. And theta also equals 5 pi over 12 plus pi. So this one we saw before, 13 pi over 12. And this one is 5 pi plus 12 pi, so 17 pi by 12. Those 4 are done. But we're not done. We still have this whole other side. So we don't put the negative into our calculator. Don't make that mistake. I do 2 theta equals, and actually we already did this. We just had those same numbers in the last question, didn't we? But anyway, I would do shift sine 1 divided by 3, and I get, this is theta, 2 theta related, 0.3398. But the difference here is, be very careful. I am negative. It's negative 1/3. So I'm in quadrant 3 and quadrant 4. So I do pi plus that and 2 pi minus that. So in fact, let's show that. Pi plus 0.3398. You don't have to show this when you're doing it on a test, but you have to get the right answers, obviously. And 2 pi minus 0.3398. And these should work out too. I've got them here, so let's just go for it. 3.4814. And this one is 5.9433. Then I divide them by 2. Remember, I still haven't divided by 2. That's that same thing. I don't divide by 2 when I have the related angle. I don't divide by 2 until I get both of them, quadrant 3, quadrant 4. When I've done all that work with the quadrants, then I divide by 2. And I get theta equals, in this case, I got 1.7407. Stop me if I'm going too fast or anything, but this is all kind of simpler stuff. 2.9717. We're not done yet. Because that's only 2 of them, and I got to go find the other 2. How do I do that? Add pi. And the answers we get for these ones, I hope I have them written down properly here, are 4, just do it on your calculator obviously, 48823 and 6.1133. Imagine somebody trying to figure this out from the note. Just looking at the note, they'd be like, what happened here? And we're pretty much done the hard part, but we're not all the way done because this, even though we can follow it and we just wrote it, still looks like a jumbled mess. So we have to write this out. Therefore, theta equals, and I got to find all of them. So I got 1.7407. I got 2.9717. I got 4.8823. And I got 6.1133. And I got pi by 12. And I got 5 pi by 12. And I got 13 pi by 12. And finally, 17 pi by 12. Good prediction in the beginning. 8 answers because it was quadratic and double angle. 8 answers. And all because it was a double angle, but we were solving from 0 to 2 pi. And if you use graphing software to graph that, you would see that somehow it crosses 8 times before it hits 2 pi. Yep.
In this semester in calculus, are we going to learn how to solve ones with a compression of more than 2, like 3?
No, I have a question. Is everybody good with this? I have just a thinking question that I'll leave up here. So your practice tonight is number 4 from the worksheet that we already handed out. I'm going to hand out your review, and I'm going to show you one thing on your calculator. But how many solutions would this have? So that's just something to think about. I think it's an interesting question. It makes you make kind of predictions like we talked about. And it's not really beyond the realm of difficulty, although if it was a quadratic, it would just be a lot of work. You know what I mean? But this one wouldn't be too hard. But it'd be a little bit different. Yeah. From 0 to 2 pi. That's right. Yeah. Very good. You would definitely need to have a domain.